Hello, this is a video going over, it's going to be the desktop presentation for Lesson 1, Topic 2. We're going to talk about technical controls. Here are the slides. It's under Topic 2. And when I'm done, the desktop presentation will be posted underneath that. So let's get started. There's a lot to cover. Alright, so toys to the rescue. So there's a lot to be said about technical controls. I'll get to the toy thing in a second, right? What are technical controls? Well, technical controls are devices, digital devices that are used to control digital assets, to control access to digital access, access to digital assets. Okay, so one common belief out there is that technology got us into this mess, and technology can get us out of this mess. However, bad business practices override good technology all the time. Okay, I can have the best firewall configured correctly, but if users are still downloading malware, remote access tools, falling for every phishing attempt that comes in, then all my technical controls are fairly useless. Well, not useless, but the deck is stacked against them. Okay, so business processes often override good technology, but we need to have good technology too. All right, well, that sounds good. What's the bad side? Well, there is a bad side to it. To quote Vonnegut, well, to paraphrase Vonnegut, I won't read this whole thing. Humans tend to build cool stuff, but no one wants to do the maintenance, right? So everyone in IT wants to buy cool things, set new things up, set up the latest IDS, the IPS, the intrusion detection, but no one wants to maintain that or check out every dead end or false positive that comes in, right? That's kind of human nature. Check the logs, right? So again, that's kind of a flaw in human nature, so be advised of that. All right. There's, of course, cost is also a bad side, right? These things are going to cost us, and when we put in technology, there could be a disruption as well. All right. So let's talk about firewalls. We're going to talk a lot about network segregation. We're going to separate our users from the servers, and our servers that need to be contacted from the outside, from our servers that should only be contacted from the inside and not allowed to be contacted from the outside. And it's going to be firewalls that do this. So let's get into firewall, how they work. Again, they're generational. Earlier firewalls were strictly just access lists, which were not ideal because there's no way to really write a secure way to write an access list that gives users the internet. All right, that's one of the downsides to access lists, right? If at some point I'm going to have to put a permit any, and that permit any is going to allow some traffic in that shouldn't be allowed in. So, all right, so let's take a look here. So best practices with firewalls. All right, I'm going to actually hit Control Tab, and there's Giphy. All right, so we're going to, which I'll find a posting. I didn't want to close it because there was one I already found for posting. Excuse me. All right, so the first thing to notice here is the security rating. All right, every interface off this firewall. Here's the firewall. That's a fire. It's a wall. It's a firewall. Every interface off this firewall has a security rating. This one's 100. This one's 25. This one's 50. This is 0. It's fairly standard practice to see the outside, which this is what this would be considered of. The internet is the outside. It's fairly standard practice to see the outside have a security rating of 0, and the inside having a 100. I prefer to give myself some wiggle room. I often make the security rating for the inside like a 90, 95. All right. Something that if I wanted to put something in a little bit later that was even more secure, I could do that. So that leads me to my next point, though. A security rating is nothing more than a interface's, well, security rating. I'm trying to think of a better way to say it. The level, how secure that network segment is, that network zone is, right? So case in point right here, the inside is the most secure. So our users over here, when they try to access this SQL database, by default will be blocked by the firewall because it has a lower security rating on this interface and a higher one on that interface. Now we can punch holes using access lists, which we'll look at that in the lab. But for the most part, by default, we're going to have the users will not be able to access the inside because of the security ratings. Now, and the good side of this, by the way, this is Generation 2 firewalls or adaptive security algorithm firewalls. The adaptive security algorithm part is essentially the firewall will punch a hole temporarily. So our users here demand the internet. They love their cat videos. Okay, so I could probably just get a picture of a cat video, but we got our cat, right? They want their cat videos. Okay, so they want to download them from the internet. Now what the firewall does is when the users go out and request a cat video, all right, let's just pick on Google. It sends out a web request out to port 80, right, from whatever dynamic port they're using, okay, and it goes to Google as an IP address. The firewall sees that conversation, all right, and therefore the firewall can create like a temporary hole and says, okay, when Google comes back and follows in this traffic, we'll let them in through that hole and send the cat video to Jim here. We'll pick on Jim. All right, that in essence is what an adaptive security algorithm is. Think of a guard at a castle wall, right? We can have merchants go in and out of the castle, or the steward of the castle, right? They go out. We've been drinking a lot of ale lately, and they're going out to buy more ale. All right. So in the morning they leave with a wagon full of empty barrels, which are the returns or whatever, I don't know. And when they return, they're going to come back with a bunch of full barrels, right? The guard can sit there and say that makes perfect sense. However, if they don't see the steward leave, or if some random merchant shows up and says, hey, I got a bunch of ale for the inside of the castle, without actually going out or no one escorting or no one making the request, the guard should question it and say, wait a sec, right? There's a secret ninja attack, right? So that's essentially what a firewall is doing, right? It's seeing the traffic that goes out and then opening a temporary hole to let it back in. All right, and that happens when you have a higher security rating going to a lower security rating. So case in point, if I'm sitting on this web server and I go out and ping Jim's computer here, that will be allowed by default, right? The DMZ will simply hit the firewall and it'll say, hey, I want to go to this IP address over here, 10.100.50.128/25. So let's say Jim's IP is 130 or 131 or something in that range, right? And it'll say, okay, I'm going to let you through. And because you're going to a lower security interface, so that's an echo request. Now Jim's PC is going to send an echo reply and say, "Oh, I heard you. Here's my pong reply ping." Right? Now the firewall knows that's going to come back. It's an ICMP message. There was an echo request coming from our web server, whatever IP address it has. Let's just say 65, since it's the first IP in that range, and it's going off to 131. Right? So the firewall routes it onto this interface and it makes notes. Says, there's an ICMP echo request, and to whatever Jim's IP is. Right? I think we said it was 131, right? And it's going to see that return come back at 130 from 131 to be an echo reply, right? And the firewall will let that through. It'll create a temporary hole. That hole doesn't stay open very long. Okay, so there you go. Now, so there's two big concepts here, right? We have our security ratings, okay, and we have our adaptive security, all right? Remember, at the end of the day, a packet is nothing more than we have our data, right? So we got data. We have our layer 4 data, which is going to be port numbers. Layer 3 data, which is going to be source and destination IP address. And layer 2, which a firewall won't care that much about because there could be routers and stuff on the other side. We're not too concerned about MAC addresses. So with all that, now second generation firewalls, and this is layer 2 footer, which is just the checksum. So with generation 2 firewalls or adaptive security firewalls, that's essentially what their function was. The latest generation firewalls are what we call layer 7 firewalls, right? And what the layer 7 firewalls do is they look into the data, right? They look into patterns. They look at the whole sequence of the data, right? They're able to look at the TCP headers at layer 2 and figure out, oh, there's like 1,500 packets coming for this one transaction. Let's look at the whole picture. Let's build up a cache and reassemble this data and see what it is, right? And hopefully it's just a cat video and no malware. All right, that is layer 7 firewalls. Those are the latest firewalls. We also have endpoint firewalls, or operation system firewalls, or application firewalls, which can help prevent access at the node level, right? Jim here has a firewall, so now they have to get through. Someone, if they were attacking, would have to get through this firewall and that firewall. However, Jim downloads malware. What's going to happen is malware is going to go out and contact the internet. Here's my hacker, by the way, right? It's going to go out and contact the server, and the server is going to ride those coattails in, right? So malware on the user's laptops do not help the situation. Matter of fact, they bypass firewalls. So that's why spear phishing and phishing in general is very successful. And we've seen it in the news so often because it's a good way to get past the firewalls. So let's talk about some other things. We talked about access control lists. Let's talk about honeypots and honeynets. And then we'll move on to IDs IPs. We can also use this drawing for that. So honeypots are essentially a server, right? So we'll just draw a box, right? And let's see if we have a honeypot. I didn't bother searching. Let's see if we got one. Honey. There we go. That's kind of good. We'll grab a honeypot, and we're going to put it right there. Oop, I guess we're going to put it over there, and I'll drag it over. Fair enough. So there we go. So there's our honeypot. Okay, it's our honeypot server. So it's just a server that's running software that looks very, by the way, this is a very vague general drawing. Obviously, a firewall would go to a switch and then would go to these workstations. You don't plug directly into a firewall. At an enterprise level, at least, with enterprise equipment, right? We'd have a switch, and then that switch would plug into the end nodes. But we'd have another server over here, and that server would look very vulnerable. We'd have an old version of Apache running, or old version of Linux kernel with a known exploit over Telnet or SSH. Something that looks very tempting. Maybe not too tempting, because a proper trap doesn't make things. You don't put a filet mignon in the middle of the woods and expect someone to fall for it, right, with a rope around it. So you might, anyway. So it's something that looks very tempting to an attacker, right? They're scanning around our network. They're looking at the DMZ. Maybe they got into this web server, and they're trying to pivot. They bump into this server with all kinds of juicy services that they can get into, and they would want to get in the server to see what other devices they can scan. They can do an IP scan and look at the other devices, right? So when they do, so the way these servers work is the moment they generate a shell, be it PowerShell or a Bash shell, it's going to generate a syslog message, or also a logging message, or hopefully, and maybe then trigger off that log message, or just trigger right off that creating the shell, and send me a notice, right, the administrator, that someone is logging into the server. Only people with malicious designs would be logging into the server. It serves no one else. It has one purpose, which is to trap people, right? And it doesn't trap them, by the way. It just simply detects them. It's not so much a flypaper situation where flies get stuck in the honeypot. It's more a covering your tracks around a barn, right, with snow. That way you can figure out if it's a fox or a raccoon breaking into the barn, right? You smooth all the tracks around the farm to figure out if it's what kind of animal's breaking into the barn, right? You're making it so you can check tracks. You can detect someone's doing things on your network they shouldn't be doing. It's not going to trap them in there, right? They can always just turn off or disconnect their network. All right. So there you go. That's a honeypot. Now there is such a thing as honey nets. If we were to build out a whole different network in here, we could make a whole honeynet network with honeypots in there. So that's also a thing. It's a definition word, so I have time to mention it. There you go, honey nets. All right. So IDS and IPS. All right. Now the key here is the middle letter, right? It's going to be intrusion something system, right? Intrusion detection system, intrusion prevention system. All right. How do these devices work? Well, they're either going to be inline or out of band, or out of line, or out of band. Those are the terms I like: inline, offline. So let's talk about that, right? It's going to come down to your configuration, right? All right. So in this case, we have an intrusion prevention system, IPS, right? And what's going to happen is, as you can see, it's in line. So it's got one point here and another connection here. So any traffic that's going to go from the firewall to the users, it has to go through my IPS. Okay, meaning my IPS can do a couple things. It can inspect the data, do layer 7 inspection if it needs to, right? And it can look for things like Jim here. I keep picking on Jim. I hope there's no Jims out there that get upset. Jim. We're having fun with that class. So I can make Jim over here. I can check what Jim's downloading, and if it's malware, I can drop it because it's going from here to here. So somewhere in that process, I simply just drop it, right? So there you go. That's an IPS, so it's preventing an attack, right? As compared to an intrusion detection system. Now you can have a IDS, intrusion detection system, in line, plugged into both sides, right? And you can also have a intrusion detection system just simply plugged into the switch, just like all these users. All these users right now are plugging into a switch. Let's just say they're all wired, right? I can also have an intrusion detection system, right, that's going to sit there, and if it sees any funky traffic on the network, broadcast traffic or something like that, IP scan, Nmap traffic, it's going to report it to me. It doesn't, and even if it's a line, it doesn't stop anything. It reports, it sends an email, right? Now, a couple points here. What these both are doing is they're looking for anomalies, right? They're looking for behavior that's weird, right? Just odd behavior. And as we know from the news, that can be problematic because we have biases and all kinds of problems. What we call that is false positives and false negatives, okay? When we see something we think is an anomaly, and if it's an intrusion detection system, it sends me an email and it's wrong, that's a false hit. Or IPS, it actually drops it because it thinks it's malware, but Jim's just trying to download his cat video, right? So how do we handle that, right? How are we going to handle the false positives and the false negatives, right? And those are going to happen no matter what. We're going to have to deal with false positives, false negatives. Most of these devices are fine-tuned, so it's going to kind of look like they're going to play with the knobs and the switches and how sensitive they want it to be when they see an anomaly. And they're going to find that where false positives and false negatives collide, that's what they're going to set it at. Okay. So it depends on how much time you have as a administrator, how many false positives you want. You can dial this up and get a lot more false positives and a lot less false negatives, right? But then you're going to eat up a lot more of your time. Okay, so there's also different ways you can scan. Again, it's looking for an anomaly, but it can be looking at it can do behavioral monitoring, which essentially means, wait, I see something that's weird, like you got a workstation here that's scanning every IP address from what I can see, and it's going through and scanning every port, right, of the 1,024 known ports. It's scanning all those ports, right? That's weird behavior, okay, and then it's going to send me a notice, or if it's IPS, it might block that IP address, right? If it's heuristic, that's more kind of looking at the big picture. My best example of this is a heuristic scanner might send me a notification saying, listen, normally we see this type of traffic on a February, the first week of February, on a Tuesday, the first week of February. Today we're seeing twice that much data. We don't know what's wrong, but something might be wrong. You might want to check that out, right? Heuristic looks at the big picture, right? It looks for, we normally see this many broadcasts, but we're seeing that many broadcasts. We normally see Jim's computer only download 10 gigs of cat videos, but today it downloaded 20 gigs of data. It says it's all cat videos, but it looks a little weird, right? So again, this is all part of the monitoring behavior. All right. Placement's another big issue. In this case, I placed it in on. I placed it in on my users. That's not an accident. I don't trust my users. Too many years working in the field, I suppose. However, it could be completely valid. Someone would say to me, "Wait a sec. Why not put it here? Why not put it on the inside?" Right? This is the crown jewels. That's the most valuable piece of software you have. Wouldn't it make sense to put IPS there, right? And it certainly would make sense to put like something else we're going to talk. Something else that's in the definitions is a DLP, a data loss prevention device that scans the type of data. Like we could tell it that credit card numbers should never go to the DMZ, right? And so if it sees that, it can block those credit card numbers. That looks at the actual data again, right? And it's looking for things that look like credit card numbers. However, I like to put the IPS here because, again, our technology is pretty good. These firewalls work fairly well. What's killing us more times than not is our users, bad behavior by our users, and that's what we talked about, having good policies and all that good stuff. And then bad administrators, like going off surfing on our web server and checking out websites that might have malware, right? So I'm a little less concerned about this. I mean, we're not the NSA. If you're working for the NSA, then you do need to be very concerned about that. But most of us are working for, at best, financial companies, and what's going to burn us more times than not is what's going on in here, right? And this is kind of why I like the IPS here. Again, some people might argue it belongs here because this has an open port to the internet. This is port 80. We let people come in and look at files on this server, right? Let's scan that traffic, right? And that's completely legit. Or if you want to be paranoid, you can put an IPS on every single network zone. That's fine too. But again, that's more maintenance. That's going to be more false positives, more false positives, right? That you're going to have to deal with. And you're going to have to maintain it. You're going to have to look at the logs, and you're going to have to do audits, and we'll talk about all that. So if you want to do all that extra work, then you should buy 3 IPSs in this scenario. Okay? But realistically speaking, we're trying to keep it simple. Keep it simple, stupid. All right. So we talked about IPS, IDs, load balancers. How do they work? Fault tolerance is a part of data security. So remember, with fault tolerance, we're going to let's pick on the web server. We decided it's mission critical this web server stay up all time. So instead of having it go from the switch over to directly to the DMZ, we have it go to a load balancer, right? And that load balancer could possibly even have obviously 2 connections going to that switch, and maybe even 2 connections going here, right? That way, if one of these connections go down here or here, right, we can also make these work in tandem, work together to give us more bandwidth and failover. So if someone unplugs one of these lines, we just go down in half in bandwidth. Or we can have it where they work as offline backups. So if we have a primary, so this would be a primary, this is a secondary, right? If the primary goes down, then the secondary kicks in, and not until the primary goes down to the secondary kick in. Or we can also have a load balancer that has that, and we have 2 servers, right? That way, if the server goes down, so a load balancer could sit there and say, okay, here's the backup server. This backup server just automatically copies the backups to the files, the HTML files, and if this server goes down, then the load balancer will detect that immediately and kick us over to the new server. That's what we call a failover, right? The primary goes down, we fail over to the secondary. And then at some point we might want to fail back to the primary. All right. So a load balancer again can combine. It can do what's called link aggregation and combine a couple NICs. It can make 2 network connections, physical network connections, turn into one logical one, increasing bandwidth and fault tolerance. All right. Up-down monitoring systems, again, there's a lot going on, technical controls. So up-down monitoring system simply will scan our network and look for any services that go down. If it does, it will notify us. Text message is usually the way to go nowadays. Access control, again, we have file systems, users, groups, and permissions. Getting deeper is that was networks too, really. We got into file permissions and access control. But again, using our file systems, using our groups, our users, and the permissions built in NTFS if it's NT, or ext4 using the UGO user group other. What we can do is we can make sure users that do not need the access, again, policy of least privilege, right? If the user does not need the privilege, does not need that right, then don't give it to them, right? Giving users every right to write to every single file is how you end up with ransomware attacks that are very successful, right? I get it. I get IT staffs are underpaid, overworked, and don't have time. And you can just simply say, "Oh, well, I'll give everyone edit permissions." Right? I'm going to go through and just let everyone edit this file. But that's how ransomware ends up taking over your network, right? Eating up all your data. You find some user that doesn't even touch that file normally, downloaded some ransomware on a phishing attack, and encrypted that database, right? So. So again, blended with a policy of least privilege. We're only going to give you enough privilege needed to do your job. Data loss prevention, DLP. Again, we talked about that. It's simply going to scan the data as it goes through. If it sees any data that's not supposed to, social security numbers, emails, any kind of personal identifiable information, PII, any PII it picks up on, it can drop it. It can even go as far as editing the data in the packet and just put X's in, or in the document. All right, it does that. SIEM is a aggregator, and it automates. What it does is collects logs from all these different devices. We have routers, we have firewalls, we have switches, we have servers. It'd be great if we had a system that can go around, just collect all these logs in one place to make it easier for us to audit, right? For us to read through these logs. And it'd be even better if this device would read through the log up immediately, and if it sees something through its glorious programming, if it sees something that it thinks needs my attention immediately, it can send me a notification. There's also Unified Threat Management, UTM. It's a device that what it does is it essentially does all this, right? It can be made up of multiple servers, but a UTM will essentially do the up-down, do the SIEM. You can, at one glance, handle some of the access control. It can query through LDAP your Active Directory permissions and groups, and try to lay that out in a sensible way. So UTMs are fairly powerful and very expensive. A really good SIEM and a really good UTM are really expensive. But that's what it's doing, is making your life easier. You don't have to look through all those logs. You don't have to keep it all in your head. It will do it for you. A VPN. So what a VPN does is it connects up to our network. So in this case here, let me get rid of some of my mad scramblings here. All right, and we'll do that. We'll keep the cat video though. All right, so let's say this is a legit user, or why don't we put another user? So we'll grab a picture of a user, a legit user. Here we go. We'll grab her, and we're gonna put it right there. Put her there. All right, so she's out and about at a conference or some good thing, and she wants to access our, well, let's make it our SQL server. And for some reason, we let her. So what she can do is establish a VPN. Now, let's just say our firewall has that feature built into it to make it easier, and it can also act as a VPN concentrator, right? What that VPN service does, or VPN server, what that will do is, from her station, it will negotiate a connection from wherever she is, Houston, Texas, the space station, wherever. It will negotiate a connection to this outside interface. And what will happen is all traffic from this point to that point will be encrypted. Okay? And then it will be put onto our network as the firewall or the VPN concentrator, VPN server, as the intermediary, right? So you have a lot of NATing, you have a network address translation, you have a lot of kind of moving from one network to another. Now, there's a couple different ways to configure these firewalls. So the big thing I want to talk about is full tunnel versus split tunnel. All right, a full tunnel says all traffic is going to go down this tunnel. I don't care where else you're going. If you're going to Google, if you're going to Disney.com, you're going to go download some cat videos, you send the data to my firewall. Now we can configure the VPN server. The VPN server can be configured to go out and download that thing from the internet and give it to them. It eats up our bandwidth, but maybe we're nice, right? But the point is, everything goes down this tunnel. By the way, everything that goes down the tunnel is encrypted, right? So it adds more security, right? By the way, when she downloads this data from our SQL server, it's going to go through the wire, and then it's going to be encrypted. So when it goes through this WAN connection, the cloud, which I have no control over, it's all going to be encrypted. All right. So a full tunnel says everything has to go down here. A split tunnel says at her laptop, right, we're going to make a decision, right? We're going to sit there and say, okay, if it's destined for the SQL database or even our web server, right, something on our network will go down the tunnel. But if you're going to Google, by all means, go to Google, right, and just go on your own internet connection. Okay. Now the big concern about that is this: what if we have an attacker that has malware on her laptop? So then the laptop has malware. It comes up and it's a reverse HTTP piece of malware. It comes up, reports to the server. The server sends commands. They're in as a remote access tool. They got Metatrooper or whatever on their laptop, and they're able to execute remote commands on our laptop, that laptop can then ride in. And if they go to the SQL database, they sit there and say, oh, it looks like there's a lot of traffic that goes to this SQL database. They can ride in on this tunnel from their laptop, right? Their laptop would use this laptop as a proxy and then ride in that down that tunnel. That's the downside with split tunnel. So split tunnel is less secure, but it is happier users because they're going out their connection. It's less slow. Also, she's downloading cat videos. Think how long it'll take to go down to our VPN server. VPN server then has to go out to the internet through our connection, then send it back down here. It's going to take forever for her to get cat videos. Not happy. Full tunnel is not as well appreciated by our users, but is much more secure. So we also have site-to-site versus remote access. In this case, the picture I drew was remote access, right? Let's call her Susan, I suppose. So Susan is the one that's making the connection there. She wants remote access in the SQL server, okay? But what if we have a different site? We have another business site, right? And we'll just draw a building over here, right? We have a building, and we have an office that's in Rochester or Springfield or wherever. If we want that office with their firewall to be connected up through the internet and then be able to still, everyone in that office hit our SQL database, we can do that. We can have a site-to-site tunnel. So from that site to this site, everything that goes down that site is going to be encrypted. Again, you can still do a split tunnel or a full tunnel there. And same principles apply, right? These users won't be happy if we do a full tunnel if they want to go out and download cat videos because they have to go through our bandwidth connection, then back out our bandwidth connection to their office. Network access control. So what network access control does is it through 802.1x, which is a network protocol that you can jump what VLAN you're on. We should have learned what VLANs are by now in either networks 1, networks 2, or networks 3. But it can jump what VLAN you're on, or what virtual LAN you're on, what subnet you're on. It can change your subnet based off credentials. How does it do that? It uses a radius server, which we talked about a lot in networks 2 infrastructure, or Taxis, older. Well, it's not really older, less used authentication system. There's supplicants, which are the clients on the device. They can be thin. There can be client list supplicants, and there can be thick clients. So the thick clients tend to do more. You can go as far as like checking the latest definitions on the antivirus, make sure they're updating their antivirus, or to do a virus scan. Every time they connect up to your network, it does a virus scan. If it picks up on a virus, the thick supplicant, it will move you over to a quarantine network, and that quarantine network won't let you in. All right. We can also have port security, which is a lot like MAC filtering. At our switches, we can only allow certain MAC addresses in, and at wireless as well. Of course, wireless is going to be inherently less secure. What can we do with endpoints? So we can have secure master images. Again, every machine that leaves IT that we set up needs to be secured. Reduce the attack surface. What do I mean by attack surface? I mean the amount of vulnerabilities that it could possibly have, right? If I've been to clients before where they had most desktops on their site running a web server for some stupid reason, and I was like, why are they all running IIS? It was all IIS, and they had some reason, some project that's now dead. But now you're increasing the attack surface. If there's a vulnerability in IIS, all these desktops are now vulnerable. So if you're not using the service, if you're not using the port, then you should disable it, right? So secure master images follows best security practices. This is the IT staff. Make sure it has antivirus. Again, antivirus works a lot like IDs IPs. It's gonna look at data at rest. Also data in use of the memory if it's a good antivirus, and even data in transit if it's going between caches or threads, actually, if it's a really, really deep antivirus. But what it's going to do is look for code that, again, is an anomaly, right? And there's lots of different ways we can handle that. There's lots of ways we can dodge it as malware makers, and we talked about that in Internet Network Security 1. Full disk encryption, something we might want to push out, where we encrypt the entire disk of our device. We can use what's called a TPM or TPM, which is a trusted platform module. It's a chip on the motherboard that stores keys. That way our user doesn't have to type in a key every time they boot up. That's going to be the synchronous key, the the key for encryption. We got patch management. Patch management is going to make sure our operating systems and our software is up to date and patched, hopefully away all the vulnerabilities. And of course, spam and phishing, which again I said is the biggest concern right now in security. We can use email gateways, right, to protect our endpoints, right. Again, Jim in his cat videos, if he gets an email saying, I got all these cat videos for you, it's a spear phishing attack. It's very focused on Jim and his damn cat videos. The email gateway hopefully can look at the URL and say, oh wait, that's on a naughty list, that's on a blacklist. Let me block this. This is a phishing attempt. All right. Remember access and integrity. Right, our job is to protect the integrity of data. That's why we want to back it up. If someone encrypts it, we want to have a backup. We'll talk about RAID a little bit later, but we have data backup, 3 copies, ideally 2 different types of mediums, 2 different types of media, either be it cloud, tape drive, which I know is old. USB sticks is not ideal because they could die, or 2 different machines, a hard drive being one machine, right? So, and 1 offsite. So you have 3 copies on 2 different types of mediums, and then 1 of those should be offsite. We'll talk about RAID in lesson 2, topic 1. But remember, RAID 0 is RAID striping. So we're going to keep part of the data on 2 disks, making it faster. RAID 1 is mirroring. We're going to keep a copy on both. RAID 5, we use 3 disks, which is striping with parity. There'll be a 3rd file, which we can reconstruct one of the other halves if it goes away, and then 0 plus 1. We'll talk about that next class, or in lecture 2.1. So fault tolerance, again, keep the concept of hot swappable. Excuse me. Can we put in a network card, or can we put in an expansion card without shutting down the machine? Site versus downtime. Do we need to go down to the site? We want to avoid downtime. Having a cold site, a backup site where we can just do a little bit of configuration, as compared to a hot site, where a hot site is everything's ready to go the moment we're down, it kicks in. Right? We talked about active ready. In other words, we have 2 devices. One's active, one's ready to take over. The failover state is where the ready now becomes the active, and the active becomes ready, ideally, hopefully. And then failback is when we go back to the primary. Okay. Laptop asset management. Ideally, on a laptop, we have software that locates it if it's stolen, or we can do a remote wipe if there's sensitive data on there. We can wipe it remotely. Okay. And the same goes for mobile devices, which we talked about in Internet Security 1. All right, so we can have network devices or client devices act as technical agents to secure our network. Firewalls segment our networks, allowing for compartmentalization. IDs IPs scans our network traffic for anomalous behavior. We need to deploy technology at the edge to secure our data as well. RAID, encryption, access control at the port, secure master images, patch management. We can use technology to smartly monitor our logs and status of all our devices. So we can use SIEMs, up-down servers, or UTMs, Unified Threat Management servers, to keep an eye on our network, monitoring it, which is tough. That's actually the tougher part. It's easy to build a secure network. Monitoring it and maintaining it is the tough part, which we'll talk about again in lesson 2, part 2. All right, I've gone on pretty long, and I will say goodbye until later. Bye.